Greetings and welcome back. In this section we have question 2 based on Newton's laws of motion. The question reads as follows: block A of mass m is connected to block B of mass 7.5 kg by a light inextensible rope passing over a frictionless pulley. Block B is initially held at a height of 1.5 meters above the ground. Okay, the height here is 1.5. Let's just slot in here. So this is 1.5 meters. So block B is held at a height of 1.5 meters above the ground, while block A is initially stationary on the ground as shown in the diagram below. When block B is released, it moves vertically downwards and strikes the ground with a velocity of 3.41 meters per second. And then the question goes on to say, show by means of a calculation that the magnitude of the acceleration of the block was this, while the block was moving vertically downwards. Okay, so with such questions, we for now 2.1, we must focus on the movement of the block B from where it was held there up down to this position on the ground level. So you realize that we are going to use the equations of motion for the movement from that point to that point. So that section here, we have to use the equations of motion. Now with the equations of motion, I always encourage students to draw up our data table. So this 2.1 with our variables v final, initial, our time, delta t, our acceleration, and the delta x, or you can call it delta y. So always draw that one. It always helps to analyze what information are you given in the question. So in relation to this movement from the top, from this position here up to down to the ground here, so we will find that we have got a final velocity of 3.41. Now I always prefer to take the upward direction as positive, so I'll take positive as upward. So meaning that anything that is moving down, I will take it as negative. So here the ground strikes the ball strikes the ground with 3.41 meters. So it was moving down, so I will take that one as negative 3.41. That is the final. Initial, it was at rest there, so it will be 0. We are not given the time, so we can put an X there or a dash. And then acceleration is what we are calculating, question mark. And then the displacement is, we are given the displacement is 1.5. So I'll take that one as negative 1.5 because it is below. Okay, the object was moving down. And then this tells us that we are going to use an equations of motion that doesn't have a t. And this equation is v final squared is equal to v initial squared plus 2a delta y. So we're substituting, we got a negative 3.41 squared will be equal to 0 squared, which is a 0, plus 2a, a is our acceleration, times delta x, that is a negative 1.5. And then squaring both sides. So 3.41 squared, 3.41 squared, that will give us 11.6281. So 11.6281 is equal to, that one is a negative 3 3a. Okay, negative 3a. 2 times 1,5, and we divide by negative 3 divided by negative 3, so our a will be equal to that. So let's calculate the a there. So I'll just take this divided by 3 divided by 3. Our answer is 3.876. It's a negative 3.876 because here we are dividing by negative, which we can write as 3.88 meters per second. So the negative means that, remember, we said downward is negative. So downward is negative, so it means our acceleration will be downwards. Okay, that solves that. And then question 2.2 is to draw a labeled free body diagram showing all the forces acting on block B after it was released. So the forces acting on block B after it was released. Now there are 2 marks here. Usually when you see 2 marks, it means that we have got 2 forces. So 2.2, as it is moving a free body diagram represented by a dot. Now you realize that there are 2 forces acting here as it is moving. One is the tension and the other one is the gravitational force, which is the weight. So we can show those forces as 1 tension and the other one is weight. So those are the 2 forces that are acting on the object as it is moving downward. Now question 2.3, state Newton's second law of motion in words. You know this one. It's you have to state it in words. So it goes as follows: the net force acting on an object, the net force acting on an object accelerates the object in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. So that's Newton's second law. The net force acting on an object accelerates the object in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. 2.4, calculate the mass m by applying Newton's second law to each block while they are in motion. So to apply Newton's second law on each block, so we can start with block B. On block B, in other words, we are going to apply Newton's second law. In symbols, Newton's second law states that F net is equal to ma. Now we have to break down the net force that is acting on block B. So we will realize this is the free body diagram that we have drawn already here. So there are 2 forces acting on block B. So the net force will be the sum of those 2 forces, the vector sum of those 2 forces, which is the weight minus tension, which should give us mass times the acceleration. Now the weight, we can break it down into mass times gravitational force, which is the mass is 7,5, Remember, block B is 7.5 kg by 9.8 minus the tension is equal to the mass again, 7.5 multiplied by the acceleration. The acceleration we are given as 3.88. So it will be 3.88. And then from there, we will calculate our T. So 7.5 by 9.8 T. So we can basically say here that T is equal to 7.5 by 9.8 minus 7.5 by 3.88. That will give us the value of T, the tension. Now let's enter that in our calculator. So we will have here 7.5. Okay, I will just factor out 7.5 here. That will be 9.8 minus 3.88. 3.88. Close that. That is giving us 44.4. So that is 44.4 Newton. That is the tension in the string. Now we are now going to use, they say, on each block. So now let us apply Newton's second law on block A. So let me bring it over here and say on block A. On block A again, F net is equal to MA. Now what are the forces acting on A? The forces acting on A, as it is moving upward, there is tension and there is also weight. Okay, those are the forces acting on A. So now tension is upward there, so we have to take that as positive. So we are going to have T. We are breaking down the net force. That will be T minus W is equal to mass, which is, we don't know, M. This is unknown now. This is our M. This unknown M here. And multiply that by the acceleration, which is 3.88. So multiply that by 3.88. Substituting the values in T and W. T we know it's 44.4. So this is 44.4 minus weight is mg, m being the mass of that particular block, times g 9.8. This is equal to m times that one, which is basically 3.88 m. Now collecting like terms, we have 44.4 is equal to this 9.8 comes over here. It will be 3.88 plus 9.8. How much is that one? That is a 13.68 m. If I'm not mistaken, let's add that up. That is a 9.8 plus 3.88. That is 13.68 m. Now what we are going to do here, of course, we want m. So our m is 44 divided by that. So we have here, let's just come here. So we'll take 44.4, we divide it by our answer. We'll get 3.245 or 3.25. So therefore our m is 3.25. That will be in kg. So we have got the values of m, 3.25. Okay, that is the question that we are trying to answer here. So we're done. Calculate the values of m by applying Newton's second law. Now then 2.5 is to calculate the maximum height above the ground reached by block A. The maximum height above the ground reached by block A. Now what happens here is that just to clear off this part here. What's happening is that when we go from what's happening here is that the distance that is moved by block B downward, which is 1.5, is the same distance that is going to be moved by block A up. So at a point, it is going, block A is going to be at that particular point. But now, because of the Newton's first law, of course, because when the block B is the ground, at what is the speed now, that will be the final speed is 3.41 meters per second. You reckon that since they are tied by is it a rope or a string or a cable, inextensible rope. So since they are tied by a rope here, so you find that at this particular stage, when block A reaches 1.5, it will also be traveling at a speed of 3.41 meters per second, but it will be upward. Now, because of Newton's first law, of course, since at that stage it is in motion, now when it hits the ground, it is going to move a further distance up. Okay, it will move a further distance up. So it will be thrown up for a particular distance. So that distance is what we have to calculate. Now, from that point to the maximum height, that distance now, or what we can refer to as the displacement. So during that displacement, the object is now projectile. In other words, it is in a free fall. The only force acting on it is a gravitational force. So we need to find now, from the time that block B is the ground, which is the same time as block A is at that stage, how many meters did the block A continue to move up? So that's what we are going to calculate. So we need to calculate the displacement, and that displacement, which is our delta y there, we are now going to add to 1.5, because at that stage it had already covered a displacement of 1.5 meters upward. So we have to apply now our equations of motion on that part of the journey. Now you reckon that this speed here, or the velocity of the block at this lowest level there, at that level, this is going to be the final, it's going to be the initial velocity rather. It will be an initial velocity. So this is acting as an initial velocity, and when it reaches a maximum height, there is going to be a final velocity rather of 0 meters per second. So we have got that piece of data there, and displacement is what we can calculate. So we can draw up our normal table, which has got our V final, initial, time, what is our acceleration? In this case, it's a g, because it is in a free fall. The only force acting on it is gravitational force. And what is our delta y? Now let's fill in that table. This is 2.5. So 2.5. Like I explained already, the final velocity is going to be 0. The initial is 3.41. It's moving upward, so it will remain positive. So 3.41 here is the initial velocity. And then time we are not given, so put a dash there. G is 9.8, but it is acting downward, so it's negative. Displacement is our question mark. What is it? So again, you'll find that we are going to use the formula for calculating the displacement, which is V final squared is equal to V initial squared plus 2a delta y. And delta y is what we are calculating. Substituting in there, we've got 0 squared is equal to initial 3,41 squared plus 2. A is a negative 9,8 gravitational acceleration times delta y. Now solving this, so I'm going to get a delta y times 19.6. I'm just bringing this one over, is going to give me 3.41 squared. Okay, let's enter it here. 3.41 squared, that is 11.6281. We had already calculated that one. 11.6281 divided by 19.6. So our delta y is going to divide that 11.6821 by 19.6, which is 0.593, 3 decimal places. So our delta y is 0.593 meters. Now what it means is, from the time the block A was in free fall, when that is when block B hit the ground, it moved a distance of 0.593 meters. Now they are saying that calculate the maximum height above the ground. So now they want the distance from the ground. This distance that we are calculating is from this level here up to the maximum point. So we have to add 1,5 plus 0,59. So adding that, therefore the maximum distance is going to be 0,593 meters plus the 1,5 meters that it was above the ground level. So adding that, we are going to get how much? 2,093 meters.